Hey guys, today I want to go over with you the written exam Zoom report for Module 3. So let me share my screen and I can show you my explanations of everything. Give me just a second. Alright, so this is Module 3 written exam Zoom report. So with the first question, we will use the divisibility test to decide which of the numbers in the graph are divisible by 2, 3, 4, 6, 4, 5, 6, 7, 8, 9, 10, and 11. We will then explain our reasoning by why these numbers are divisible by each other. Well, we learned a bunch of the divisibility rules in Module 3, so you can go back and look in your textbook to find those rules. So 684 is divisible by 2 because its end digits are even. It is divisible by 3 because the sum of the digits is divisible by 3. It is divisible by 4 because the number that is represented by its last two digits are divisible by 4. It is not divisible by 5 because it doesn't end in a 0 or a 5. It is divisible by 6. It is not divisible by 7. The number is not divisible by 8 because its represented numbers of the last two digits are not divisible by 8. It is divisible by 9 because its sums of its digits are divisible by 9. It is not divisible by 10 because it does not end in a 0. And it's not divisible by 11. So you can see this graph that I've made, and I have all of my reasonings for why the numbers are or are not divisible by each number from this side. All right, let's move on. So number 2, I had some hard times figuring this out, but now that I figured it out, it's fairly easy. So this is the casting out nines. In this problem, we'll be using casting out nines method. To use casting out nines method, first replace every number in the calculation by its remainder when divided by 9, based on the divisibility tests for 9. The remainder is the same as the sum of the digits of the original number. So actually, parts A through D are all false, but we're going to prove through casting out nines method that they're false and that there was a mistake in the calculation. So 416 plus 7,490 plus 69,844 is equal to 112,790. Well, through basic calculation, we already know that that is not correct. So what we're going to do is do the casting out nines method to prove this. So you would add the digits of the integers, as I'm doing right here. The arrow will point you in the way we need to go. 4 plus 1 plus 6 equals 11. 7 plus 4 plus 9 equals 20. 6 plus 9 plus 8 plus 4 plus 4 equals 31. So now we need to cast out the 9s from those sums. So pretty much just subtract the 9s. 11 minus 9 will equal 2. 20 minus 9 equals 11. 31 minus 9 will equal 22. So let's move on with those sums and add those. So we're pretty much just starting over again. 2 plus 11 plus 22 equals 35. So let's start casting out the 9s again. 35 minus 9 is 26. 26 minus 9 is 17. 17 minus 9 is 8. Well, now you're at a number that is below 9, so you can stop there. So now to prove that this isn't correct, we're going to take the sum from the original problem and add the digits like we did previously. So 1 plus 1 plus 2 plus 7 plus 9 plus 0 equals 20. Subtract the 9, that will give you 11. Subtract 9 again, that will give you 2. Well, 8 is not equal to 2, so that proves that this statement is false. We will follow the same steps with all parts of this problem, so let's try the second one. So 8,550 plus 6,888 plus 6,029 equals 23,892. Well, this isn't correct. We know that through basic calculations, but let's prove it. 8 plus 5 plus 5 plus 0 equals 18. 6 plus 8 plus 8 plus 8 equals 30. 6 plus 0 plus 2 plus 9 equals 17. So 18 minus 9 will equal 9. 30 minus 9 equals 21. 17 minus 9 equals 8. Let's move on with the sums from those problems. 9 plus 21 plus 8 is 38. Minus 9 will give you 29. minus 9 will equal 20. Minus 9 again equals 11. Then subtract 9 one more time, and it gives you 2. So let's take the sums from the original problem. 2 plus 3 plus 8 plus 9 plus 2 equals 24. Well, 24 minus 9 is 15. 15 minus 9 is 6. Well, 2 and 6 are not equal to each other, so that proves that this is a false statement. In number 3, it's very easy actually. It could be great for a visual learner. In part A, it wants you to show which rods in the image to the right that will measure 9 rods. So an easier way to think about this is, what are the factors of 9? The answer is the factors of 9 are 1, 3, and 9. So the rods that will measure a 9 rod are the 1 rod, the 3 rod, and for obvious reasons, the 9 rod. Part B, which rods will measure the 6 rod? Again, what are the factors of 6? My answer ended up being the factors of 6 are 1, 2, 3, and 6. So the rods that will measure the 6 rod are the 1 rod, the 2 rod, the 3 rod, and again, for obvious reasons, the 6 rod. Part C, part A and B. Use part A and B to show the greatest common factor of 9 and 6. We've already listed the GCF in parts A and B. So my answer is 9 and 6 have 2 common factors. Well, what is the greatest one? They have 1 and 3. Well, the greatest is 3, so the answer would be 3. In part D, we're going to place the 10 rod and the 8 rods side by side. This forms an 18 train. Show all the rods that will measure the 18 train. Well, what are the factors of 18? 1, 2, 3, 6, 9, and 18. In part F, we're going to briefly describe how you might use these colored rods shown to demonstrate the notion of GCF to children. Well, the greatest common factor of 2 different numbers can be determined by the length of the longest train / rod that will measure both numbers / rods. Okay, this is a fun one. Let me find my paper. So we're going to be finding the least common multiple through this graph. So in the first one, we're looking for the least common multiple of 48, 25, and 65. Well, what is a prime factor that can go into 48, 25, or 65? Well, 5 goes into 25 and 65, so you'd bring 5 down from the 25, 65 would go to 13, and 48 you would just bring it down because it does not go into 5. So now we can use a 2. Well, 48 divided by 2 is 24. 5 divided by 2 is not possible, so bring the 5 down. 13 divided by 2 is not possible. Bring the 13 down. We'll use 2 again. 12 divided by 2 is 6, so bring the 6 down. 5 does not go into 2, so you bring the 5 down. 13 does not go into 2, so you bring the 13 down. 6 goes into 2, so that's a 3. Bring the 3 down. 5 doesn't go into the 2. 13 doesn't go into 2. And now we have all prime factors. So that would give you 13 to the first, times 5 to the second, times 3 to the first, times 2 to the fourth. And your least common multiple will end up equaling 15,600. And you do these the exact same way. It's all very simple once you get the hang of it. All right, so number 5, it's asking us how many revolutions will the smaller gear have to make before A and B are again in the same position? Well, the first step is to find the least common multiple. So you see here I did prime factorization with each. The least common multiple ends up being 336. And your next step is to divide the least common multiple by the smaller number in the smaller number of gears. So that's 48. So 336 divided by 48 is 7. And that ends up giving you your answer of 7. Here's the magic square. Magic square is an array of numbers arranged so that the numbers in all rows and all columns and the 2 diagonals have the same number. So this, I had to do a little bit of research, but I figured out how to do it. You're wanting all columns, rows, and the 2 diagonals to be equal to the same sum. So first, let's determine the magic sum. You can find the sum of the given integers that we've already been given. We know that the sum of each now is the same. So you need to name the sum, the magic sum as x. Well, excuse me. All right, let the magic sum be represented by x. Find the sum of the given integers. We know that the sum of each now is the same. Earlier we named this sum as x. 3 times this sum is the same as the total sum of all the integers. Now we will just use trial and error to find out how we could place these numbers for the magic sum to be -9. So this is really just a bunch of trial and error. You'll try and get all the sums the same. Luckily, I ended up getting it on the first try. I think it's just luck. But that is how we do that. Just a bunch of trial and error, really. All right, that is my Module 3 written exam. I hope you enjoyed. Thank you.